Designing and implementing Passkeys. So please welcome Justin Scott. Over to you, Justin.
Good morning, everyone. Thank you for attending. I hope everyone is enjoying the content today. This presentation is Understanding and Implementing Passkeys. And this was a presentation that was first given at Adobe ColdFusion Summit in Las Vegas. The title slide has that date on it. Unfortunately, when I was updating the slides for this, LibreOffice corrupted my presentation, so I had to fall back to a PDF version of the prior one that I had given, but all the content's essentially the same. So just a tiny bit about me. I'm Justin. I started as a bulletin board sysop in the 90s. I've been using ColdFusion since a layer ColdFusion 4 in 1999. Built hundreds of applications, have been an IT director, VP of technology, and I'm currently the Chief Information Security Officer with Smart Communications. And I hold a CISSP certification in information security. And as of Summit, I'm also now a Adobe certified ColdFusion professional. So if you had attended my previous presentations on advanced encryption, I had said at the time that passkeys are coming, but that implementation was kind of a mess. Things have gotten much better on the passkey front since then, and it's become a more mature technology. User agents and browsers are now properly supporting passkeys, and passkeys are now supported by all of the major password managers like Bitwarden and 1Password, the Google Password Manager built into Chrome, etc. So what are passkeys and why am I talking about them? So passkeys are defined as a phishing-resistant form of authentication that's based on asymmetric cryptography and are tied to device biometrics or a master password. And it's sponsored by the FIDO Alliance and most major tech companies, Google, Microsoft, Meta, etc., are all supporting this. They are essentially a replacement for password-based authentication for web applications. And so everybody that's attending this session, I would assume, has at some point in their development career coded a login form that looks similar to the one that's on the screen. The old way of doing things, we typically identify a user based on a username or email address or some other identification token, and then they authenticate with a password. And that, as far as authentication factors go, would be something that you know. This historically has been supplemented with additional factors, such as a time-based one-time passcode, emailed links, SMS messages with codes, etc., as a supplement to passwords to add a second factor. So something you know is the password, and then typically something you have, like access to your phone to receive an SMS message or access to your email box to receive a verification link, for example. And all of this has worked well for many years, but unfortunately there are a number of problems that come with this authentication methodology. One of which is having to deal with storage of passwords and proper hashing and management of those passwords, which can be complicated. And they're also very phishable. So we all get SMS spam messages with links to login forms that look accurate, and we're plugging credentials into places where they don't belong. This has also been supplemented with the concept of single sign-on, where we're using a third-party identity provider, typically something like Microsoft Entra ID, a Google Workspace account, or a Gmail account. Apple supports single sign-on. Okta acts as a third party that a lot of corporations use. But basically any provider that supports SAML2 or OAuth compatible authentication services can be integrated. This also presents some challenges because now your authentication is dependent upon a third-party service and the user's account being in good standing with that service. So, for example, if you implement single sign-on and tie it to people's Facebook accounts and somebody gets locked out of their Facebook account, well, now they're also locked out of your site because they can't authenticate through the chosen identity provider. So that adds a risk and a third-party dependency that some people don't consider to be an acceptable risk. They want to keep their sign-on in-house so that your own web application is not dependent on somebody else's being available. So some of those issues with passwords that we talked about, people forget their passwords. We have to handle passwords server-side. People reuse their passwords all over the place. They're phishable. People will put in their passwords on websites that they shouldn't because they're tricked into thinking that it's a site that they are trying to go to but can't. And even the best of us can fall victim to that. Passkeys solve all of these problems because they can't be forgotten, they're automated, they're stored in password managers, and they can't be exported by design. So some of the benefits to switching to passkeys is that passkeys are automatically generated by the browser or the user agent using a public-private key pair. And the private key for the passkeys are always retained in secure storage and are not exportable by design. They utilize asymmetric cryptography, and the server side, so your application, only ever sees the public key half of that equation. The private key is stored by the user on their own device or password manager, and your website or web application gets the public key, which by definition is public. So if your database is exfiltrated by a nefarious actor, they will only ever see the public keys, which they can't really do anything with. Similar to, if you're properly hashing passwords in storage today, would have a similar effect. Like those hashes are not reversible. And similarly, the public key storage doesn't do anything for an attacker if they were to get those. As far as reuse, passkeys are uniquely generated every single time. So there is no reusing a passkey from one site to another. By design, they're not exportable out of the standards compliant password managers and are therefore not phishable or shareable. So Netflix, I'm sure, would love that because the passkey can't be reused. You can't share that with another family member and have them sign into the site from somewhere else unless they have access to your password manager directly. Now, implementation is maturing, but it's still early. There's not a lot of awareness among the public for passkeys. That is beginning to change as some of the larger providers like Microsoft and Google and Apple and Amazon, etc., are pushing passkeys onto users. For example, with Microsoft accounts today, they go with a passkey first policy. So it is actually possible to have a Microsoft account that is entirely passkey driven and you don't even have a password anymore. And we'll get into transitioning to that for your applications later in the presentation. Some terminology that we need to understand about passkeys that's going to come up involves one, you're going to see RP. This is important. This is the relying party, which essentially is your server, your website, your application. And these, the relying party identifier is expressed as the root domain of a credential. That can include a subdomain. So if your website is sampleenterprises.com, then that would become the root of your relying party within the passkey. And similar to cookies, they can also be more granular. So you can specify subdomains that passkey would be valid in. So for example, if you wanted to have an authentication, centralized authentication server, you could have auth.sampleenterprises.com and limit the passkey's use there. And if, say, a rogue actor set up a different host name on your domain, attacker.sampleenterprises.com, the passkey wouldn't be valid there because you've limited that passkey to only be valid on a certain subdomain. Basically the same way that cookies work, where you can specify root domain or subdomains for cookies. In the passkey terminology, the browser is what you expect, Chrome, Edge, etc., that exposes a JavaScript interface to the authenticator. The authenticator does not have to be the browser. It can be, In the case of like Google Chrome and the Google Password Manager, Google Password Manager is the authenticator in that case, but it can be external. So, for example, if you have a Bitwarden or 1Password extension installed into Chrome, that can become the authenticator to store and present passkeys from that piece of software instead of the browser. So those are considered separate pieces of software from the passkey terminology, but they can be the same, but are typically different. And finally, the credential ID is going to be the unique ID of a given passkey. And we're storing that in our database along with the public key to identify it. So with that terminology out of the way, we mentioned earlier that passkeys utilize asymmetric cryptography. If you haven't spent a lot of time in the security side of things, or you're not well versed in encryption, asymmetric cryptography is the method of encryption that use different keys to encrypt and decrypt the same data. So you encrypt with one key. For example, you can encrypt with your private key, and then that data can only be decrypted with the other key. So if you encrypt with your private key, you decrypt with the public key, or vice versa. In the industry, the security side, this is known as a key pair, which consists of a public key that can be shared. It's not considered secret. And you also have a private key, which by its name should be private and should only ever be known to the user or the applications that are using it. This is also the basis of the public key infrastructure, and is how SSL and TLS certificates operate. SSH authentication operates this way. And asymmetric cryptography, because of the nature of it, is much slower than symmetric cryptography, which is what most people think of when you think of encrypting data. You're typically thinking of symmetric cryptography, where you're using the same key to encrypt and decrypt the data. And so your goal is to protect that encryption key. With asymmetric cryptography, you have two different keys, one of which encrypts, the other one decrypts, and they can go both ways. So somebody can encrypt with your public key so that only you can decrypt it with your private key. And we'll see how this applies, but it's important to remember we're using asymmetric cryptography with two different keys in this case. And it's all handled under the hood by the browser and the authenticator. But from a development standpoint, you want to understand the innards of how this works. So passkeys also have some additional requirements beyond what you would typically see with passwords. Passwords were developed way back, pre-internet, and were bolted onto the internet applications over time. Passkeys have some additional requirements. So your application must run over a secure TLS channel, so it has to use HTTPS. They only work in a secure context. Now, you might be thinking, well, when I'm developing locally, I'm developing against a local host domain on my own PC. That's not going to be using a TLS certificate. So how does that work? Well, the browsers treat localhost domains as secure for this purpose. So if we have our example, like sampleenterprises.com, I might be using sampleenterprises.localhost for my local development. And if you're not aware, Chrome and the other browsers will treat any domain with a .localhost extension and will bypass DNS resolution and automatically send those requests to your loopback address on a local computer. If you try to do this using just the IP address, so that 127.0.0.1, for example, that is not considered secure for this context. You have to use a domain name with a .localhost extension for local development. And you also need a browser that supports the WebAuthn extensions, which they all do at this point. Firefox, Edge, Chrome, Safari, everybody supports the WebAuthn APIs at this point. So when we think about a traditional authentication workflow, we're going to see typically a sign-up form. We're collecting the user's information, part of which is a password that, if we're doing things correctly, will be hashed and stored on the server. And then there's a separate login process where we are then identifying the user with a username, email address, or other identifying token, and then asking them for their password, which we then either hash and compare the hashes, or if we're using a modern hashing algorithm, there's a verification function separate from the hashing function. Passkeys work in a very similar manner, and there's some terminology around this. So the sign-up process would typically map to what Passkeys call a registration ceremony. I don't know why they call it a ceremony. It's just a protocol, but they want to sound fancy. So during the registration ceremony, and this does not have to be a part of the sign-up process. It can be, but typically as applications are being upgraded from passwords to passkeys, the registration ceremony can happen anywhere in your application. Can happen post-login, can happen in their account settings screen. People can have multiple passkeys tied to accounts. So you might have a registration ceremony occurring as part of your account management process and workflows. But it works very similar wherever you use it. But the registration ceremony basically maps to the sign-in, and then the authentication ceremony would be mapped to the login process, and that is typically where passkey authentication ceremonies occur, is during login, because you're using the passkey instead of a password for authentication. So the process for both is very similar. In the registration ceremony case, the relying party, or your server, is creating a registration challenge when it's requested to do so. Typically, that's done through a fetch API call back to a script on your server, and you're going to return some JSON information, which JavaScript is then going to pass to the credentials API by calling navigator.credentials.create, passing that object in. The authenticator will then latch onto that information and generate a key pair and return an attestation to the JavaScript, which then returns it to the server. We're going to see all of this in detail and the JSON objects that get passed back and forth here in just a little bit. But the authenticator, whether it's built into the browser or you're using an extension, is going to authenticate the user typically through biometrics like Windows Hello, fingerprint reader, master password for something like one password, and then it's going to generate that key pair and return it. Once the browser returns that attestation to the server, your server is going to verify that the attestation is correct, that it is properly, it's a properly encrypted challenge using the user's private key. And then you are going to store the credential ID and the public key with their account, just like you would with all the other information you're collecting at sign up. But again, it doesn't have to be during sign up. It is typically a separate part of the process. And similarly, during authentication, when the authentication ceremony gets triggered, your server is going to generate an authentication challenge, pass it to the server, to the browser's JavaScript engine, which is then going to call the navigator.credentials.get method and ask the authenticator to sign the challenge using the passkey that is stored within the authenticator. After, typically the user would be prompted to say, do you want to use this passkey, or you need to insert your USB key if you're using a hardware key, or enter your master password, or like Chrome will use a PIN or Windows Hello or something else to authenticate the user. At that point, it will unlock the private key that's stored on the authenticator. It will sign the challenge that was issued by the server and then return that back to the browser, which then sends it back to the server, which then verifies that signature against the public key that's stored with their account. So you issue the challenge, the user basically encrypts that challenge with their private key and sends it back to you, and then you decrypt it with the public key to verify that the challenge is still correct, which then proves that that user has the private key associated to that passkey and should be allowed through. This all sounds complicated, but it's all handled by a little bit of code that we're going to see. There's a bunch of JavaScript, some server-side code, and a little bit of database work to implement all of this. And it's not terribly complicated once you wrap your head around all the the various concepts here. So the registration ceremony, we're going to look at some of the details for that to start with. So, and we're going to demo all this later too, so you can see it in action. So our first step during the registration challenge is for the JavaScript code on the page to call the API on the server. So here we're fetching a challenge from the Passkey-API ColdFusion template. And we're just going to post to that with an application JSON object, and we're going to build a JSON object with an action value, say get registration options. We're going to specify the user's username that they are currently either logged in or registering with, and what their display name is. So we'll send the user's full name, and then we're going to drop that into an options data object within JavaScript. So the JavaScript on your page will call this, and the object that is going to be returned by your server is going to look something like this. So we're going to say that the operation was successful. This isn't a passkey specific thing. These options are where we get into the passkey implementation. So we have our RP, or our relying party. So it's going to be sample enterprises, and our domain samplenterprises.localhost. We're going to include some user information, the ID of the user, their name, display name, and then we're going to generate a random cryptographically secure challenge. And we're going to specify that we're going to allow this challenge to be signed using two different public key algorithms. This gets a little bit technical, but the common ones are going to be an elliptic curve algorithm or an RSA algorithm. The elliptic curve is a little more secure. It's pretty widely supported. RSA is an older format. It's bigger, slower, but it's has a much wider deployment. Both are supported by all the major browsers. And our authenticator selection is a bit important here because we can specify different requirements for the authenticator portion. The important one is going to be our authenticator attachment. Here we're specifying platform. There is another option that we're going to talk about in a moment as to what those are, but platform is going to be the one you're going to look for. And we're going to say we want the key to be resident within that. And when we issue this, we want to verify that the user is present. So we're going to say that that's preferred. There are some other options here, but these are the recommended options. We're also going to put a time limit on this and say this is only going to be valid for 1 minute or 60,000 milliseconds. And we're not going to issue an attestation with this one. So that platform value, typically what we're going to want is platform for the authenticator type. This is going to be things that are built into the platform that the user is using. So for Apple devices, it's going to utilize Face ID or Touch ID for authentication. Windows can use Windows Hello. 1Password is going to use your master password. So these are going to be the types of authenticators that we want to target. For most cases, it's going to be platform. It's bound to a specific device or ecosystem and is very convenient. If we specify cross-platform, this is telling the device that we want a portable key. So this is going to require an external device like a YubiKey or other security key via USB, or there are some hardware tokens that operate over NFC or Bluetooth. These are going to be dedicated hardware devices that are portable across all the platforms, but the vast majority of our use cases are going to be for public users out on the internet that don't have a hardware token of some kind to work with. So typically we're going to want platform because that's going to specify the built-in software-based systems. And if we're using a password manager like 1Password or the Google Chrome password manager, those are portable from one device to another. They sync to their own cloud. The private keys are held within those systems, and they are, for all intents and purposes, portable. But the way that the protocols were designed essentially was that a passkey would be tied to a single device. The password managers make them more portable across devices as long as you're signed into an account. So platform is typically what we want. In a very high security environment, if you're doing military work or DoD or government contracts, cross-platform then becomes an option. Or a secure corporate environment where that those users are going to have a hardware key that they're plugging in via USB or they're syncing over NFC or Bluetooth in order for those passkeys to work. So they're stored offline, essentially. I recommend supporting both for flexibility, but typically platform is what you're going to be looking for. Once the server has returned that JSON object back to our web application, we are going to have a little bit of JavaScript code that's going to create a public key option. We're going to extract the options value from that JSON blob that our server returned. We're going to create a challenge that's base64 URL encoded. So we decode that and put it here, and then we extract our user information. And this JSON object is in the format that's needed by the navigator.credentials.create. So here the JavaScript is, to rehash step one, was asking the server for a challenge. We're now unpacking that challenge into a different JSON format, and we're passing it into the navigator.credentials.create method and waiting for the response. So the user at this point would be prompted to create the passkey, enter their master password, authenticate through Windows Hello, etc., and is going to return a credential object. So here we have our credential blob that we're returning. So now that we have that back from the authenticator, we're going to say we have a registration response, and we're now going to call the passkey API back on the server again, and we're going to stringify all of this registration data that we are unpacking out of that credential. So I'm not going to go through all the details of this, but essentially the credential that we're creating in our registration data object is going to extract information that we got back from the authenticator. That's going to include the ID of that credential, the client data JSON response, the attestation objects. This is all stuff coming out of the authenticator that we're going to extract, and now we're going to send that back to the server and await the server's response. And the server is just going to respond with a basic object that just says, yep, we registered that successfully. Here's the ID number, and it was successful. And then your JavaScript can do what it needs to do with that to tell the user, okay, it registered. Or if this came back and said, well, there was an error because we couldn't talk to the database, or that's a duplicate passkey, which should never exist. If there was an error condition of some kind, then we would return a different message to the user. Similarly, with the authentication ceremony, it's almost exactly the same as the registration ceremony, just some slight differences. So we start with that same step one. We're going to get the authentication options from the server. So our web page, its JavaScript is going to call our passkey API and say our action now is to get authentication options for a given user. So we're still identifying the user by username, and then we're asking the server, what are the options that this user can log in with? Basically, we want to see, do we have a passkey stored for this user or not? The server is then going to respond if we have a passkey stored and say, yep, yeah, here's the credential that's allowed. Here's that ID number. It's a public key. We're going to give them 1 minute or 60,000 milliseconds to respond. We're requesting that the authenticator verify that the user is present. Our relying party ID, again, our domain name that we're using as the basis for our passkeys, and along with our a new challenge that we're going to ask the authenticator to sign. This information from the server basically tells the authenticator what domain to look up the passkeys for, the ID if we have one to target a specific passkey. And this allows credentials, if you look up the specs, you can include multiple passkeys, you can leave it blank. Then the server will just present all the passkeys that are stored for that user if they have more than one. And once we have that JSON object back to our web application, we're going to do the same thing. We're going to extract some information out of that and build a new JSON object that includes our challenge, the allowable credentials, the ID, and the authentication options. And we're going to send that authentication object to the navigator.credentials.get. And that's going to trigger the authenticator, whether it's Google Password Manager, 1Password, Bitwarden, Windows, Hello, whatever, to find and retrieve the passkeys that are valid for that user. And if they have one, to sign the challenge after the user has selected which passkey they want. And If we're using the cross-platform options that we talked about a moment ago, the user would be prompted to insert their USB key or load their Bluetooth app and sync it across Bluetooth. And the goal is to unlock that passkey on the user's device and to sign the challenge. Once that challenge has been signed, we get our return back from the authenticator. Now our JavaScript on our page is going to assemble a new JSON object that's going to include our credential from the authenticator. So it's going to include the raw ID, the authentication data, the signature, all of the information that the server will need to verify that response, including our signed challenge. So now we've assembled that object. We're going to run fetch again, call our passkey API. We're going to post and say, we want the action to be to authenticate this passkey that's included here. And at that point, we're going to wait for the server to respond. And if it's not successful, so this is going to return another just basic JSON object that says whether it is successful or not with a message. If it's not successful, then we just throw an error and say, yep, that authentication failed, and we can ask the user to re-verify and send them back through a different process. Or if it was successful, then we go ahead and perform our normal login routine. We set their authentication token, put it in a cookie, update the database, whatever we need to do to handle our user login in our application at that point. So how do we do all this in ColdFusion? There are a number of challenges in implementing passkeys in ColdFusion for now. And one of which is that the passkey implementation, because it was developed by the FIDO Alliance, was originally designed for hardware authentication tokens. And so they made some choices during the original FIDO credential designs that are not very web friendly, because this was not designed for the web originally. And so one of those is that we use base64 URL encoding. If you've been developing for a while, you're probably familiar with base64. There are functions to encode and decode base64 encoded data. The URL format makes base64 data URL safe. So there's certain characters that can be output as part of a base64 encoding that are not inherently safe to put on a URL. But base64 URL encoding makes base64 safe to pass around on URLs. ColdFusion does not have built-in functions for this, nor does JavaScript for that matter. So some of the calls that we're seeing where we have these base64 URL encode, base64 URL encode, these are all functions that are defined in my own application to handle those things. This is not a native JavaScript function. So you would have to get or write a base64 URL encode decode functions in order to support this. Internally on the server side, some of the passkey data that comes out of the authenticators is going to be further encoded using what's called CBOR. It's the Concise Binary Object Representation Protocol. Most web developers have probably never heard of this. It's mainly used in like low power IoT devices. It's designed to be wire friendly for low powered kind of devices like USB keys and the authenticators that are built in. The closest mapping to this for what most people are familiar with would be JSON, the JavaScript object notation. This is just a binary format. Again, passkeys use asymmetric cryptography. ColdFusion does not have any built-in functions for asymmetric cryptography at this time. And so on the server side, you either have to drop down to Java's encryption libraries or roll your own. There are some external libraries. Yubico has a good one for passkeys for Java, and WebAuthn also has a Java library that can just be imported into ColdFusion that will provide for many of these functions. It's not simple to implement in ColdFusion today or like the legacy versions of ColdFusion, but it can be done with some effort. And during ColdFusion Summit in Vegas, it was announced that ColdFusion 2026 will have native passkey functions that the hope is will make this a lot easier. I've not seen beta versions or anything like that at this point, But if Adobe is doing with Passkeys what they've done for everything else in ColdFusion, I suspect there is just going to be a generate passkey function and a verify passkey function that will generate all the JavaScript and all the backend stuff for you and make this much easier to implement in newer versions of ColdFusion once the 2026 edition is released. Again, I don't have any special information about this other than that it was announced that they will be including functions that will manage all the passkey stuff for you. So that will be forthcoming from Adobe, and I'm excited to see what they're doing on that front. So let's look at a demo of all of this in action. We've been talking about all these JSON objects going back and forth and JavaScript code to manage all of this stuff. But from the user standpoint, what does this actually look like and how does it actually work? So what I have is a sample enterprise SaaS application. So this is my sample enterprises.localhost. This is running on Adobe ColdFusion 2023 with current patch level. And it's just a basic web application that was set up to handle these authentication workflows. So if we look at our sign up process, very traditional. We're asking for the user's information. We're asking them to establish a username and a password, confirm their password, they agree to terms of service, and they can create an account. Everybody should be very familiar with this workflow and this process. Similarly, our login, we're asking the user for their username or email address, but you'll note we're not asking them for a password at this point. Most login forms would ask for both. We're only asking for the one. And so I've got a PK demo account that I'm going to sign into, and the application asks the server for the login options. I do not have a passkey stored for this account, so it's going to prompt me for my password.
Hey, Justin, sorry to interrupt. I think we're still seeing the demo and code screen.
Oh, my apologies. The screen sharing must be stuck on that. So let me stop sharing and share a different window here.
Yeah, we can see now.
There we go. Okay. So just to back up for a second. So we have our regular sign-in process. Since you didn't see this before, we're just asking the user for their information, username, password, to establish their account. Very straightforward. Similarly, our login screen, we are only asking for the username at first. So we're going to give the server our username. It's going to check to see what sorts of credentials we have stored and how we're allowed to sign in. We do not have a passkey for this account just yet, so it's going to prompt us for our password. We say, here's our password, sign in. Great, welcome back. We've got our dashboard, all just sample stuff. So now we're signed in. So this application does support passkeys, and so one of the things we can do is, as our during post login, is we could prompt the user and say, hey, we support passkeys now. Like, would you like to add one to your account? Here we just have a call to action button. So we're going to say, yeah, we want to create a passkey for this device. So this setup passkey button is going to trigger the authentication ceremony that we talked about. So when we click this button, we're going to get an API call. When we click the next button here. So we go to our screen, we're going to name this passkey locally. When I click the create passkey button, it's going to trigger the registration ceremony. It's going to ask the server to give me a challenge, and it's going to trigger the Chrome Password Manager to add this passkey to my account. So Chrome Password Manager is going to pop up and ask if it's okay. Hopefully that window will be included as part of the screen sharing. So now we have the server has returned that object. It's asking the authenticator, Google Password Manager in this case, to create a passkey. And so it's verifying, like, hey, this website wants to create a passkey for your account. And I'm going to say create. So Google Password Manager has created that passkey and saved it to the Google Password Manager. And the server has returned some information. The UI here is a little buggy, but tells me that password key was created successfully. And so now I have a passkey stored on my account. Now, before I show the login, one of the things that we have on the sample application is pretty standard profile management. I can edit my name, I can change the password on my account, but we also have a manage passkeys section. So I can register more than one passkey and associate it to my account here on the website. And the reason you want to support multiple passkeys is that users are typically accessing our applications with more than one device from more than one ecosystem. So for example, right now I'm logged into this application on my laptop and I'm using Google Chrome on a personal profile. So that passkey is linked to my personal Google password manager and my personal Google account. But if I want to access this device using Safari on my iPhone, then I would need to log into the application from that device and add a new passkey to my account, which would then add an additional passkey that's stored within my Apple iCloud keychain that's tied to my iPhone. And so now I have two different passkeys that are allowable and permissible for use on my online account, but they're stored in two completely different ecosystems. So Apple has one of my passkeys and it's synchronizing that across all of my Apple devices. So I can use Safari to log in with my passkey that's stored there, or I can sign in on any of the web browsers that are logged into my personal Google account, and Chrome's password manager has that passkey. So I have two different passkeys stored and I can use either of them to access my account. And if say my iPhone gets stolen and no longer have access to that passkey, then I can come in here and remove it, which is why it's good to allow the user to name their passkey so so the user will know which device or which ecosystem that passkey came from. Typically, in the current implementations, the various providers do not talk to one another, and the passkeys are not portable or exchangeable between ecosystems. So if I establish a passkey like I have here on my Google password manager account, I can't export that passkey and then import it into my iCloud account. They're completely separate environments, separate ecosystems, and currently passkeys are not portable between them by design. And that's to prevent phishing. So you don't want somebody to trick you into exporting your passkey out of, say, the Google password manager and then emailing it to them. That's just not a possibility with the implementation. There is a protocol that FIDO is in the process of developing right now, along with major tech companies, that will allow passkeys to be portable between ecosystems. But it will be basically a protocol between those providers. Like you wouldn't be able to export your passkey and then import it somewhere else. The providers would talk directly to one another to transfer those passkeys in a secure way, again, to prevent phishing. There are some people, especially those in like the free open source community, where the belief is that all data should be freely available and it's my data and I want to be able to do what I want with it. So there are people who have built passkey managers that allow for passkeys to be exported. I don't recommend using them because again, once you export that private key, it becomes phishable and you can start moving it around and that gets dangerous. So the recommendation is to stick with the standard password and passkey managers that are implementing this in a proper and secure way. For now, we'll just keep the single password on this account, but it is available. I can rename it. I can remove it from the account so it can't be used, or I can add multiples. And it's recommended that if you want to support multiples, and you should support at least 10, typically you'd store it in a different database table and it would just, be an unlimited number of passkeys that you could have on a given account. But if you wanted to limit it in some way, that's fine too. So now we'll log out of the application. So now we're signed out. We'll go back to our sign-in screen. Again, we're using our PK demo account. And we'll hit continue. And now, instead of prompting for the password, it's going to ask me to continue with my passkey first and foremost. I do still have the option. Let's say I'm signing in from somewhere else where I don't have passkey established yet. The server knows I have a passkey, but it doesn't know which ecosystem I'm in. I'm not asking for the passkey yet. So I can bypass that and still go back to my password, or in this case, I can also establish recovery codes. So as a method to, if I forgot my password or I lose my passkey, I still do have a way to get back in. But here we're going to use the passkey. So this is going to trigger the authentication ceremony that we talked about. So this is going to generate a request to the server with a challenge and to tell the authenticator to present, to sign the challenge and present whatever passkey the user has stored. So at this point, Google's password manager comes up and says, oh, yep, for the relying party sample enterprises.localhost, here's the passkey that I have stored. It's in Google Password Manager. If I had a hardware key associated with this, there is this like use a different passkey option where I could then insert a like hardware-based token or FIDO device that would have my password passkey stored. But here it's stored in Google Password Manager. So I just click on that passkey. The Google Password Manager unlocks that private key. It signs the challenge that was presented by the server. Hands that back to JavaScript, which then sends it back to the server for verification. The server verifies that that challenge was properly signed by the proper private key stored in the user. It decrypts it with the public key that we stored in the database, and everything matches up. So it allows the login, and now I can set my session token cookie and handle my authentication just like I would traditionally. And that passkey can also be removed. So we see it was created today, last used today. Let's say I just don't want to deal with this passkey anymore, so I'm going to just delete it off my account. So now that passkey is gone. There's no more passkey stuff here, and it's prompting me to do a setup on it. Now if I log out and log back in again, it's going to prompt for the password again because that passkey was removed. It is still stored in the Google Password Manager, but because the website no longer has knowledge of it, it's going to prompt me for the password now. So that is the full workflow for passkeys. There are some alternative methods for the sign-in. So in our case, we're specifying that we want a passkey for a specific account. There is a variation on this where your login screen can essentially ask the browser for all of the passkeys that are stored in that particular password manager for the entire domain. So if you have multiple users, it'll present all of them. Typically, there's only going to be the one, and you could actually sign the user in with a single click, basically saying just sign in with passkey or identify that a passkey is present in the password manager, and then just use it to sign them in, and that would cover the identification and the authentication. One of the things that Amazon has done is basically try to inject a passkey at various places within their website. So if you go to Amazon's website and you go to their order management and order history, they actually try to generate a passkey like unsolicited. And the browser will then just ask you like, hey, do you want to store a passkey for this site? And most people will just be like, sure, yeah. It's a really odd choice on their part to put it there, but that's what they've done. And I'm sure they're getting a lot of people to establish passkeys without even realizing it by doing that. Typically, you would want to have it more direct, the better, clearer communication with the user about what you're doing there. So let me switch back to the slide deck.
A quick time check. We have 5 more minutes left. We'll have to wrap up within that.
Sure. So another thing that I just want to put on everybody's radar that's related to this is called device-bound session credentials. We're all familiar with cookies for managing session tokens and the like. Device-bound session credentials are positioned to replace cookie-based session tokens, and for this, a lot of the same reasons that passkeys are here is, the cookies are stored per session, they're portable, they can be stolen, they can be exported. The device-bound session credentials use public key cryptography to tie session tokens to a specific device or user agent so that they can't be exported or stolen. In the past, we've had things like session hijacking because you're on a public Wi-Fi network and anybody can get access to that traffic. The device-bound session credentials rotate constantly. They use stronger integrity and mitigate cookie harvesting. Still an emerging technology, but if you're interested in this kind of thing, I recommend you just go do a Google search for device-bound session credentials and just read up on it a bit, because it's coming, and this is probably what I'll be doing presentations on next year about how to implement this new style. Transitioning to passkeys, typically, like I showed in the demo, you would want to have your traditional workflow and then have an add passkey option. Educating the users as they go, and gradually shift to a login workflow that highlights and prefers passkeys. And once your user base is mostly on passkeys, you can force that as part of your sign up and registration process as a condition of use of your service, and then require it going forward. Like I said earlier, Microsoft's accounts actually, they don't even, the option to have a password on your account is kind of buried at this point. It uses passkeys by default out of the gate. Recommend that you support at least 2 passkeys, but the more passkeys you support, the more resilient your users will be able to have access to the account. Just don't limit it to 1. And do we still need passwords? For now, yes. Keep password support for users that don't understand passkeys, but nudge users into that direction for passkey registration on new accounts, and allow them to fall back to a password or recovery codes if the passkey is not available. And as far as recovery strategy goes, I also recommend implementing support for recovery codes, like 10 single-use 8-digit codes for the user to keep offline that allows them to recover their account in the event that they lose their password, passkey, access to their email, whatever. Most of the major vendors support recovery codes at this point. I recommend that you do the same as well. So roadmap, add passkeys alongside your passwords. Allow people to opt into a passwordless experience, promote a passkey first experience, and optionally support full passwordless accounts. Passkeys plus device-bound session credentials are going to be the future of authentication. I'm glad that Adobe is supporting passkeys in ColdFusion 2026. And the ecosystem is always improving and will help you and your applications to stay competitive in an ever-evolving environment. So let me switch back to the other window. Apologize if people have been asking questions, because I have a very small laptop screen. So, so I'm just looking at the chat real quick. If there are any questions that people have, then please add them back into the chat, so I don't scroll back through the whole thing. But I'll look at a couple here. In your opinion, will passkeys outmode authenticator apps? Eventually, yes. Steve asks about that. I think the time-based one-time passcodes are a good anti-phishing solution for now, but passkeys mitigate the need for that and automate the workflows. It's faster and easier than using time-based use codes. Passkey support in 2026. Yes, Adobe has announced that. I don't have details about it just yet, but they have announced that support is coming. And given how they have implemented other things in the past, I suspect they are going to turbocharge that and make it very easy for people to be able to implement passkeys very easily in the ColdFusion applications in the future. In past presentations, my goal was to release the Sample Enterprises demo application, but I've decided not to do so because I would prefer people upgrade to ColdFusion 2026 when it comes out and use the native functions rather than trying to force it back into older versions, which is buggy. And because there's no CBOR encoding and all that, it's much easier. If you want to implement that, go get the WebAuthn Java library and instantiate that in your applications if you want to use it in older versions. I think the difference platform versus cross-platform. Microsoft stated that Outlook.com mail app can use passkey, but others still need a password. What if I want to log into my computer with my phone? Can I use platform? That gets outside the scope of web applications. I don't know if passkeys are going to be supported as options for logging into operating systems. It's kind of outside the scope of what we're doing here. On the phone via password manager and the user logs in from a desktop, what's the expected prompt behavior? That's an interesting use case. There is a variation on the login process where if you are asking for a password and your password manager does not have the passkey inside of it, one of the options that can be supported is the use of a QR code. So your authenticator application on the user's browser will present a QR code that you can then scan with your phone, and the phone will generate the passkey and sync it via Bluetooth back to the device. It's very clunky. There's very few use cases for that, but it is a supported workflow. That particular workflow is also a little bit phishable because those QR codes can be spoofed, and then your phone is essentially generated like signing a challenge and then sending it to the wrong place. So I don't recommend using that particular workflow. Much better to use a password manager that will sync your passkeys between your devices. So if you're using a third-party password manager like 1Password or Bitwarden, they will do that and sync the same passkeys across your desktop and your phone. So if you wanted to use a single passkey and not have different passkeys in different ecosystems, then you would be able to support it that way. That's the preferred method. And yeah, Sean says 1Password works well, and that's what I use myself. And yes, does work very well. With that, I think
Justin,
we're at about time.
you also have the $50 gift card that you can give away.
Let's give that to Joy, who had the question about password manager between the desktop and the phone. I thought that was an insightful question. So that if we could mark her for that, that would be,
Right.
would be good.
Yes. Yeah. So if it's all done, then thank you, Justin, for the wonderful session. Thank you for joining us today.
Thank you all very much. If there are any follow-up questions or anything like that, just search my name on LinkedIn, Justin Scott. That's the best way to get in touch with me, or go to my website at darktech.org. And a copy of this slide deck is available there if anybody is interested. And with that, thank you very much for Adobe for inviting me to give this presentation. Hope you all enjoy the content today. And thank you all very much.
Thank you.